2.5 Admins, episode 94. I'm Joe.
I'm Jim.
And I'm Alan.
And here we are again. And before we get started, you've got a job position to plug.
Yes, Clara is looking to hire a full-time ZFS developer. So if you have experience working in the kernel or on file systems and would like to join our team and work on ZFS with a bunch of us, then please do get in touch and via the website in the link in the show notes.
Let's do some news then. And the first one is that it has been proposed that millions of IPv4 addresses may be freed up.
Yeah, so there's a bunch of ranges of IPv4 addresses that are reserved. We're familiar with a bunch of those, like the ones we use for internal networking, like 10./8 and 192.168, etc. But there are a couple of bigger ranges that are reserved for other things that it turns out we don't necessarily need so many for. For example, 240/4, so that's 256 million IPs, are just reserved for the experimental range, or what used to be called Class E. Those have never been used on the internet and could be made available. The only problem is lots of people have routers with rules that say, no, that IP is bogus. If you get a packet that says it's from that IP, they're lying. And so we're going to have to adapt to get people to remove those and deal with that.
For those of you who are router admins or firewall admins, the default rules that you've seen that say reject bogons, that's what we're talking about.
The places we're worried about with this are not individual people's home routers and so on. This is more big institutional things that are going to break things. And in those cases, these are mostly hand-curated configs that somebody wrote at some point, not something that's built into the software. Although some of them maybe, like Jim mentioned there, just have a block bogons policy or whatever.
There are a lot of shipping policies out there for various projects that block bogons by default. You'll see it in the comments, like why that's being blocked and what it is. And it's not just firewalls either. Like you'll see rules in Spam Assassin and similar mail filtering projects do the same thing. They'll get rid of anything that is coming from bogon network space because they're like, well, this is obviously not legit, so the hell with this, we're going to throw it away. And it's going to take a while to get rid of all of those rule sets and all the applications and devices that use them once they make the decision to free up those ranges. There's also the problem, although I have less sympathy for this, there are certainly organizations that use bogon space internally as though they were private address spaces like 192 or 10 dot or 172.16, my personal favorite.
I don't know why people are misusing that. Like, I understand you maybe have other networks too and you don't want to overlap, but there are 3 giant ranges of private IP address space. I don't see why you would need to go use 240 range or whatever. Although also I remember back in the day when I worked at the power plant, the power company here had a giant allocation, like a /16 or something. And they just gave every machine a routable IP except for they blocked it at the edge. And so they weren't actually routable. Like they were never announced to the internet, but they used their whole IP space instead of just using private IPs. Because they owned them. And it's like, I hope by now that they've sold them and just used private internal space or something, but definitely saw things like that. And I know like a lot of colleges and universities have giant allocations that they don't really need. Mm-hmm. Like I think the local college here has 65,000 IP addresses or something that they really don't need that many of.
I've seen small businesses with fewer than 20 employees that were using the entire 10./8 subnet for like their LAN.
So in addition to opening up that previously reserved space from the experimental range, they're also looking at doing most of the multicast range. So there's only a small bit of it that's actually used by software, and so they'd open up the rest of that. But one that's more likely to cause some problems for people is they want to constrain the loopback. So instead of 127/8, they basically only want to give the first, I think, /16 of that to loopback and have the rest of it be routable.
That's going to break a lot of squirrely stuff.
Yeah. And at first, I imagine, just break some people's perception. If you see an internet connection coming in from 127.240.something, you're like, that's loopback. Why is that coming from the internet? And probably even more firewall rules that say, hey, if it comes from 127/8 and it's coming in on your NIC, that's bogus. Check it out the window. And all of that will have to change.
Not just rules. Every consumer router out there is going to be using that as loopback space. And it's not just a firewall thing. Like you actually have to change its routes to tell it, no, that's not yours anymore.
So yeah, they want to do 240/4.0/8. So the actual addresses that start with 0 dot something, they want to make those usable. That's also slightly complicated because really the only special address is supposed to be 0.0.0.0. But if you've ever noticed with the way a lot of older Unix programs parse IP addresses, because an IP address really is just a 32-bit integer, if you just try to ping the IP like 127,000, it will turn it into the IP address like 0 dot whatever that works out to be. And so that might be a problem. And then, yeah, like you mentioned, the 127/8 and then 225/8 through 232/8. So all but the first /8 of the current multicast range.
Weren't they also talking about getting rid of the .0 on every local subnet as a broadcast address?
Well, specifically, they mentioned that .0 hasn't been a broadcast address and has been usable since 2.4 BSD in the early 80s. And almost every operating system's network stack is based on that original 4.2 BSD open source code, even like Windows and so on. So it's got to be at least like 3 decades since there was anybody's software who actually tried to use the .0 address as a broadcast. But yeah, you know, if you could think of every subnet out there, especially when you're doing CIDR and you have really small subnets like a /29, having 6 usable IPs instead of 5 in every one of those subnets would actually be a pretty big win if people's routers and stuff wouldn't block it.
Well, I feel like we need to clarify something here also. Just because you're not using .0 as a broadcast doesn't mean that it's actually usable either.
Right. This would mean it would be usable.
Right. Which will be a change. I know there are a lot of network stacks out there that you can't not allocate a broadcast. They won't let you.
Right. It's just the broadcast should be the all ones address, not the all zeros address.
So this is just a proposal at this stage. How likely is it to be adopted, do you think?
Pretty good. There are already patches for FreeBSD, OpenBSD, and Linux. There's also, they're operating an overlay network. So there's like a kind of like a VPN you can join to test this with other people that are doing it. And in general, they proved that it works. It's mostly going to be a matter of when can we get to the point where enough people will be able to reach these IPs that people will be willing to use them. If you remember, it took quite a while for the 1/8 range to become usable again. But nowadays, you know, lots of people are using, was it 1.2.3.4 or whatever as their DNS? Or 1.1.1.1 is the Cloudflare one, right?
Yeah, 1.1.1.1.
Yeah. For a long while, that wasn't a usable IP address either, and we eventually got there.
But do you remember what actually got us there? Cloudflare deciding to use it as the DNS server that everybody in the whole world could address, that was really what flushed the problems. There were still a ton of problems with people that had rules about that space and wouldn't allow it to be routed to. And Cloudflare adopting it is what got people to actually start fixing those problems.
Yeah, and so I think part of the reason for this conversation is like, we proved that we can do it, so let's get it done, because otherwise we're just never going to get anywhere.
Just force Google to use that as the raw IP address that google.com resolves to. People fix the issues.
Yeah, if google.com was suddenly 127.254. something.
Whole lot of firmware updates rolling out that week.
Yep.
I mean, maybe you'd have better luck asking Microsoft to do that with Bing, but nobody'd bother patching it.
Right.
Windows Subsystem for Linux 2 is coming to Windows Server 2022. So previously, WSL 1 was available in Windows Server, but this is a big upgrade to the proper VM version, not just the translation layer.
Right. And previously, this was only available on like the desktop Windows 11 or whatever. So having it on server, where it could probably be quite a bit more useful, especially just having access to that. I know even on my desktop machine, for years, I went and installed like GNU Win32 or whatever, so that I would have the proper versions of grep and sort and so on, even at the Windows command line, like CMD, just because those tools and using pipes is so powerful and so useful, being able to do that on server stuff, especially now that Windows has OpenSSH built in and so on. It just gives you a lot of flexibility that you didn't have before.
Yeah, for me, it was Cygwin before the WSL days, and it was a lot better than not having the tools on the command line, but it still really sucked rocks compared to having a proper Linux or BSD shell. WSL is a huge improvement. Even WSL 1 was. WSL 2 is better yet, and the best part, in my opinion, of WSL 2 is not just the improved performance with it being a VM rather than just sort of an emulation layer, but the modern WSL 2, not the one in Windows 10, but the one that you get starting in Windows 11, it also includes graphical and audio support. And there were a lot of people when this feature was first announced that were like, okay, sure, but what do you want that crap for? And for me, there was a very obvious answer, and that was Virt Manager. It allows me to manage all of my, KVM-based Linux virtual machines from a Windows workstation running Virt Manager. And more importantly, it allowed me to give, clients who were Windows admins with no real Linux experience of their own, they didn't really need to have a full-on Linux workstation, wouldn't have been comfortable with it if they had it. But it was very, very nice to be able to give them that console access and be able to more easily start, stop, and, pull local consoles on their virtual machines.
So what are the advantages on the server, though?
Just not feeling gimped compared to coming from your Windows 11 desktop and finding things missing. Honestly, that's really what it kind of boils down to, is just not feeling artificially constrained when you're on the server rather than a desktop.
Yeah, and the same thing you see with things like Dockers. Like, you want to build it on your desktop and then deploy it on the server. And if they're the same environment, then that makes it much easier. Okay,
this episode is sponsored by Kolide. Go to kolide.com/25A to sign up today. Kolide sends employees important, timely, and relevant security recommendations for their Linux, Mac, and Windows devices right inside Slack. Kolide is perfect for organizations that care deeply about compliance and security, but don't want to get there by locking down devices to the point where they become unusable. Instead of frustrating your employees, Kolide educates them about security and device management while directing them to fix important problems. Kolide helps deal with some of the many issues that are not solved by locking down devices, like instructing developers to set passphrases on unencrypted SSH keys, finding plaintext two-factor backup codes and teaching end users how to store them securely, and convincing employees to uninstall evil browser extensions that may sell their browser history. You can try Kolide with all its features on an unlimited number of devices, free for 14 days, no credit card required. Try it out at kolide.com/25A. That's KOLIDE.com/25A. Let's all laugh at Spotify and Megaphone. They had an outage of more than 8 hours because they forgot to renew an SSL cert.
Yeah, well, I'm guessing that means more that they forgot to monitor their SSL certs.
Yeah.
There's the old adage, it's not DNS, it can't be DNS. It's always DNS, it was DNS. But sometimes no, you let your SSL cert expire.
So this took down Megaphone, which is the host for a lot of very popular podcasts. And it cost people money because people who do timely podcasts about sports and popular culture and stuff, people just couldn't download those episodes. So people are very mad at Megaphone and Spotify, who owns Megaphone.
Yeah, Spotify bought Megaphone at the end of 2020 for like $230-something million. But yes, one of the great things is certificates are usually issued in the UTC time zone. So it meant that it expired at 8 p.m. on a Monday rather than during business hours, right? And I imagine that partly contributed to how long it took to get fixed. But as Jim and I will tell you, the important thing is that you set up monitoring.
Mm-hmm.
This was quite timely because my certificate was coming up for renewal pretty soon. But as soon as it got to less than 21 days of time left, I got an alert saying, hey, this certificate is going to expire in 3 weeks. The next day, I renewed it and got it pushed out. And now that certificate's good for another year because you can't get more than a year plus a day or something anymore. But I agree with that as well.
And for those who haven't heard my rants on this topic before, the proper way to monitor this is you have your monitoring system actually grab your web page, certificate included, and parse the cert and figure out when it expires. And if it's soon, then it says, hey, boss, come fix this.
Yeah, there's a Nagios plugin that actually calculates the number of days until it expires and complains. We also have ours check all the intermediates because we had that problem a couple of years ago where not the certificate itself expired, but the certificate of the company that issued the certificate expired. And they had cross-signed it with two certificates, one that had been trusted for 5 or 10 years but was expiring next year, and a new one that was relatively new and wasn't in everybody's trust store but worked for another 10 years. But there was that bug in OpenSSL where if anyone in the chain was expired, even if there was still a valid path through the chain, it would balk at us. And that set off our alerting and helped us deal with the problem and make sure that our people trying to watch videos streamed on our platform didn't run into the problem as much. Although we still had a couple of Rokus that had ancient SSL versions and had problems. And we had to go and manually rip that certificate out of our bundle so that our web server wouldn't include it in the trust chain.
Man, this is bringing some unpleasant flashbacks because for a few years now, everything of mine has just been let's encrypt, and God, it just makes life so much easier.
Well, it kind of reminded me of something very similar to that, is that processes you don't do very often are the ones that don't get tested very well. And so, yeah, kind of to Jim's point, something like Let's Encrypt that forced you to rotate it often enough that it got annoying so you would automate it properly has really helped with a lot of things. And because of the way we have to use this SSL certificate for a couple things that have to be fully restarted when you change the certificate because Java is stupid and so on, is the only reason we're not using Let's Encrypt for that. And once a year dealing with expiring certificates. But we've migrated as much as we can to Let's Encrypt because it's just that much easier. Especially once they got the wildcard support, that made a big difference for us. But we were looking at other aspects of our businesses, like really, should we have something where we set a short expiration and we make sure we deal with this rotation frequently instead of occasionally? Because otherwise, we're going to try to just, we'll deal with it manually when it comes up. And then it's like, I don't remember how to do this. And you end up taking a lot more time than if you just automated it properly.
Well, yeah, that's the beauty of CertBot, right? It just does it all for you.
I've never used CertBot. I use like acme.sh, but same idea, yeah.
I use CertBot, and yeah, it handles everything for you. It's very easy. The only real complaint with CertBot is if you've got a single server with literally thousands of domains on it, CertBots can't really handle that. Which I ran into with one person who basically they only had like 2 or 3 actual sites, but just a never-ending rotation of domain names. They'd pick up any domain name that they thought might maybe be relevant to their business and point it at the same site. And that got unwieldy. I eventually had to have a conversation with them about how it was not really practical to have 6,000 domains pointing to the same website.
Yeah, or before Let's Encrypt had wildcard support, FreeBSD had every subdomain had to have its own SSL certificate. And we eventually ran into the rate limiting on how many we could issue and renew in one day and having to stagger them.
Well, the issue with CertBot is CertBot only gets a single cert for all of the domains that you're covering.
Oh, it's doing like one of those UCCs or whatever?
No, it's SANs, subject alternative names. So there's only so many subject alternative names you can have on a single certificate, and roughly 6,000 from memory is how many that guy had, and it was too many.
I'm just horrified at the idea of ASN1 having that many items in a single entry.
Yeah.
Like I was thinking this was just star.domain.com times 6,000 separate certs, which I'm sure CertBot would choke on as well, but
these weren't even subdomains. They're just completely unrelated domains, just
right.
Anything that grabbed his fancy.
Right, but like clarasystems.com and clara.systems are 2 separate certificates from Let's Encrypt. We didn't tie them together.
If you did it with CertBot, they would be. You would grab one cert for everything, which is also obnoxious if you're doing like a shared hosting setup, like if you're running a small web server and maybe doing hosting for like 10 or 12 small businesses. CertBot will put them all on one cert, and only one domain shows as like the proper domain that the cert is assigned to. So you'll still get the green lock in your browser, if your site is one of the ones that got a SAN instead of, the common name. But if a user goes and looks at that certificate, they'll be like, I
don't know if it was related to CertBot or not, but Cloudflare, if you do the not your own SSL certificate version, the cheapest version where they do the SSL for you, you get in a bundle with other people. And I think it was some site for, a mutually loathed politician was in the same cert bundle as some Nazis.
The really unpleasant thing about the way the CertBot handles it is you don't even get to choose which domain gets the CN and which ones are SANs. It's just kind of a luck of the draw type of deal. Ooh. So you're liable to wind up with, my mind's not in the right space to come up with examples because they're all way too obscene for the show. But you get the general idea, right?
Yeah. But yeah, like we even have a system set up where we do Let's Encrypt for our customers. So there's like a host they go into, and we basically set it all up with acme.sh so that they get a cert done that way so that we can push it out to the CDN for them.
In this article on The Verge that we'll link to, they point out that the certificate that expired was a 2-year cert that started in May 2020, which was 7 months before Megaphone was acquired by Spotify. I can't help but think that might have something to do with why this got forgotten about.
Partly. The other one is you can get interesting thing happen with there. Another cert we had expiring last month ran into this problem where we had bought it as a 2-year certificate, but it was around the time that they introduced the new limit on how long the certificate could be. So the certificate was expiring, but at the certificate authority, we had an option to reissue it with the longer expiry date, except for it only added like 7 days because of just added a year to it when it had like a month left because our monitoring went off early enough. But it meant that we had more than the allowed amount of days. And so we had the option to reissue the certificate to get the extra like 4 days that were left on that certificate. We're like, no, we'll just buy a new one. Thanks. But if it lined up differently for them, they might have actually had a certificate that they thought didn't expire for another week or two, but had been clamped by the maximum allowed lifetime of the certificate when they lowered that limit from 5 years to 13 months or whatever.
No, I was just assuming like a different IT department came in and somehow it didn't make it over.
Yeah. If you're Spotify and you acquire them and you get this megaphone thing, you're probably not thinking about their SSL certificate.
The one guy who had the calendar notification on his phone, yeah, he didn't make it through the merger.
Yeah.
Right. Or, the one address that the certificate authority sends a reminder to. Exactly. And this is why you have to have the monitoring.
Okay, this episode is sponsored by Linode. Go to linode.com/25A, support the show, and get $100 free credit. From their award-winning support, offered 24/7, 365 to every level of user, to ease of use and setup, it's clear why developers have been trusting Linode for projects both big and small since 2003. Deploy your entire application stack with Linode's one-click app marketplace, or build it all from scratch and manage everything yourself with supported centralized tools like Terraform. And check out their managed MySQL, Postgres, and MongoDB databases that allow you to quickly deploy a new database and defer management tasks like configuration, managing high availability, disaster recovery, backups, and data replication. Simple and fast to deploy with secure access, their flexible plans include daily backups. So go to linode.com/25A, create a free account, and you get $100 in credit and support the show. That's linode.com/25A. Let's do some free consulting then. But first, just a quick thank you to everyone who supports us with PayPal and Patreon. We really appreciate that. You can go to 2.5admins.com/support to learn more about it. And remember, for $5 or more per month on Patreon, you can get an advert-free RSS feed. And if you want to send in your questions for Jim and Alan, or your feedback, or anything really, you can email show@2.5admins.com. Another perk of being a patron is you get to skip the queue, which is what Charlie has done. She writes, 8 months ago, when I first started building my home lab, I foolishly purchased several 2TB Seagate SMR hard drives. When I went to build my ZFS-based media server, I realized my error and promptly purchased the equivalent total in 4TB CMR drives. My question is there a good use that I can put the SMR drives to? For example, I know they are not suited to a ZFS pool, but could they be used as part of a backup server that I can sync ZFS snapshots to without incurring performance penalties? I guess I could use them to build a backup server that I can do simple rsync to, in addition to a fully capable ZFS backup server. Any suggestions?
My suggestion is going to be for backup server use. They are Seagate SMR drives, not Western Digital. So while they're far from ideal for ZFS use, they're not out of the question, especially in something like a backup server. A resilvering would absolutely suck, but unlike the Western Digital SMR drives, they should not just randomly start dropping out of the pool and, causing all kinds of havoc. I see a lot of people who have the Seagate, specifically SMR drives, posting in RZFS, talking about having run them for years and not loving them, but they work. With that said, yes, you can absolutely also use those things in like a Synology NAS or what have you that uses conventional RAID and not ZFS on the back end. And those tend to have a little bit fewer problems than ZFS does. But in general, I would just build my backup server out of that and not worry about it. And, just put that lesson in your pocket and try to avoid buying SMR drives in the future.
Yeah, that's what I did. I had 2 Barracudas, which are like the real low-end ones, and it handled it fine. Performance was terrible, but I'm mostly connecting to this thing over Wi-Fi anyway. And so, who cares if I'm only writing at like 20 or 30 megabytes a second?
Yeah, it's mostly that because of the way the RAID works, you're writing small bits to all the drives instead of one big sequential thing, and that can hurt it a bit. And then, like Jim said, the Seagates actually will work and not randomly time out and so on. So they won't be fast, but it will work. If you are concerned about the performance, using mirrors, configuring them as mirrors instead of a RAID Z will give you a bit of that performance back, partly because with OpenZFS 2.0 and later, A resolver on a mirror will do this system called sequential rebuild, and it will be much more sequential and therefore less random, and it won't conflict with the SMR feature as much, because SMR wants to basically have big chunks of the drive that are append only. And so if you're writing to them all out of order, it has to read and write the entire zone all over again, like it was trying to write 512 byte sectors to flash when it's got, a 4K sector size or a bigger erase block. You're basically getting that same concept on the hard drive, except for it's because the sectors are overlaid. And so it's having to rewrite the whole 256 megabyte zone because you changed a little bit of stuff out of order. But by using mirrors, the rebuild will be much more sequential and you'll suffer less of that. But that only happens during the resolver, which hopefully with your pool is only a couple of times in its lifetime, not like it's something you're doing to it every week.
Also, using larger record sizes will help quite a bit. The major difference between a ZFS workload and a conventional RAID workload, when you're talking about a striped array especially, is that a conventional RAID, like Linux kernel RAID, is typically going to write in, like Linux kernel RAID specifically, writes in 512 kilobyte chunks. And what a chunk means in this term is the amount of data written to an individual drive as part of a stripe. So a full stripe on a Linux MD RAID set, whether it be RAID 5 or RAID 6, is going to consist of each drive getting 512K worth of data written to it, data on, N of the drives, and then, 512 kilobytes each of parity on the remaining drives. Even if you're using RAID Z and not mirrors on ZFS, as long as it's a relatively narrow stripe and you've got record size set large, you can have pretty much the same workload. If you set record size equals 1 meg, for example, and you've got a 6-wide RAID Z2, then you're effectively going to be writing in 128 kilobit chunks instead of 512, which is, it's smaller. It's not enormously smaller, but with your record size at default of 128 kilobytes, that same relatively small 6-wide RAID Z2 VDEV, you're going to now be doing 32 kilobyte chunks. And that workload will absolutely screw with SMR drives hard. When I investigated the WD-RED, specifically SMR, I wanted to try to figure out, another site, Serve the Home, had already done a really great analysis showing just how badly those drives fell over when used with ZFS. And people all over the internet were saying, what are they doing? They can't possibly have tested these things before they left the factory. Western Digital's PR people kept saying, well, they work fine. Of course, we tested them with RAID. We tested them in all the commercial NASs, and they're great. So when I got one of those things and started testing it, what I wanted to find out was, okay, we know it doesn't work with ZFS. I want to demonstrate first that, yes, it does work acceptably with conventional RAID, which it did. And then I want to isolate what it is about the ZFS workload that makes it fall over. And in fact, you don't need ZFS. You can replicate the effect of a ZFS write workload with the default 128 kilobit record size by just streaming 32 kilobit writes to the drive. And in fact, yes, if you stream 32 kilobit sequential writes to that WD-RED SMR drive, it falls over on its face really badly, really quickly. So you want larger record sizes, you want smaller stripes, or ideally mirrors, and then you'll be good.
Okay, Bradley, who is also a patron, skip the queue. I'm setting up a home server that runs Plex and Nextcloud, and I'm planning on using ZFS. I came across an old blog post from 2018 on Jim's site about tuning ZFS, and I'm wondering if the advice there is still accurate and relevant.
The short answer there is yes. It was largely still accurate and relevant already, but when I saw that question come into the queue, I reviewed the post in question and made a couple of relatively minor alterations. And so it is 100% as of today in 2022, Jim Salter approved.
Yeah, especially for media or whatever, I would say this is correct. If your Nextcloud has a lot of not media files, so documents and stuff that aren't pictures, then using compression as a standard for that might give you slightly better compression, but that's pretty minor and it's a trade-off for more CPU time. But yeah, I would say that Jim's tuning advice here is correct.
Right, well, we better get out of here then. Remember, show@2.5admins.com if you want to send any questions for Jim and Alan or your feedback. You can find me on Twitter @Joe Ressington.
I'm @JRSSNet.
And I'm @Alan Jude.
We'll see you next week.